Okay, children, today we will discuss about the refractive index of water. That's what refractive index normally. What is meant by refractive index? Okay, children, refractive index. Children, refractive index, if you remember, I told you definition of refractive index in Snell's law, children. Snell's law. What did I say? Ratio of sine of angle of incidence to sine of angle of refraction is constant, and that constant is called refractive index. I told you already refractive index definition. I told you in Snell's law. What is the definition? Ratio of sine of angle of incidence to sine of angle of refraction is constant, and that constant is called refractive index. Don't write like this, children. You're writing full forms in exam. Apart from this, refractive index, one more definition is also. The refractive index is also defined as velocity of light in A by velocity of light in given medium, whichever medium. Suppose if it is water, you put here water. Suppose if it is glass, you put here glass. Up is arrow, children, always. Up is arrow. Suppose here diamond, they say, you put here diamond. Down only will change because down only will change. So other definition of refractive index is ratio of velocity of light in A to velocity of light in given medium. Velocity of light in A, don't say velocity of A. Velocity of light in A. Velocity of light in air is constant, children. What is its value, anyone? 3 into 10 to the power of 8 meters per second. This is refractive index. Okay, children. And refractive index also in critical angle I gave one formula, children. 1 by sine c I gave formula. 1 by sine c, if ever you remember, where sine c is called critical angle. Also I gave refractive index is equal to real depth by apparent depth. What is real depth by apparent depth? What is real depth by apparent depth? See, children, this is water. Imagine this is water. If you put a coin here, that coin, light will come like this. See here, children, this is denser medium, this is rarer medium. This is water, this is air. So denser to rarer, light moves away from the normal and reaches to the eye of an observer. When same light is extended back for that fellow, the coin appears here, the coin appears here. Actually, children, this is called real depth, and this is called
Apparent depth.
apparent. Apparent means appearing depth. Apparent means appearing depth, children. So real depth is actually this much is real depth, and this is apparent depth, children. We have to take from the top, not from the bottom. Okay, children? Like this, real depth by apparent depth. This is also one formula. Okay. Apart from this, children, we also have absolute refractive index. What is absolute refractive index? Absolute refractive index is defined as refractive index of any medium with respect to refractive index of A. Refractive index of A is 1, children, always remember. Okay. What is absolute refractive index definition? So many times they are asking in board exam, children. Refractive index of any medium compared to refractive index of A is called absolute refractive index. Means we didn't understand, sir. I will say, suppose, children, the refractive index of diamond is 2.4. What does it mean? Means refractive index of diamond with respect to refractive index of A is 2.4. No, sir, we didn't understand. Suppose refractive index of water is 1.5. What does it mean? Refractive index of water compared to refractive index of air is 1.5. Suppose refractive index of glass is 2.5, children. What does not 2.5? 1.7. What does it mean? Refractive index of glass with respect to air is 1.7. So any refractive index which we say in normal language is comparison with air. Air is 1, no, so no problem. These all are absolute refractive index. What is absolute refractive index? Refractive index of any medium compared to refractive index of air. Refractive index of any medium compared to refractive index of air is called absolute refractive index, children. Okay, and some more definitions or formulas are also, children. Refractive index is equal to sine A plus D by 2 by sine A by 2. That I told you in prisms, children. You see prisms video, you understand how we got this. So major formulas which we use is this one and this one. That's all, children. This both only we will use so many times, children. Some numericals we will discuss, children. All this theory I will put in the description, children. Please read, go through that. This full theory I will put in the description. Please go through the description. You will get all these things, children. Please, very important, all these definitions. Okay. Yeah, we'll do some numericals basing on this. Basing on this, we'll do some small numericals, children. Very small numericals. Okay, first question. Children, angle of incidence is 45 degrees. Angle of incidence is 45 degrees. Angle of refraction is 30 degrees. What is refractive index? So which law we use here, children? Which law we use? Anyone?
Sine of angle incidence by sine of angle reflection.
So we will use Snell's law. What is Snell's law, children? Mu is equal to sine of angle.
Sine by
Sine
sine
of
refractive.
So sine 45 by
Sine 30.
Sine 30.
So sine 45 is 1 by
1 by root 2.
by 1
by 2.
This will go up, children. So refractive index is equal to
2 by 2 by root 2.
Rationalize, children. So 2
Root
by root 2.
2 into
root 2 by root 2, 2 root 2 by 2.
So refractive index is
root 2.
1.414. Can anyone tell what will be its units?
No units.
Very good. No units. Refractive index has no units. Please don't write units, children. This is refractive index, children, for that question. Okay, children, you have to do carefully, children. Please don't put any units. Second question. Refractive index of water. Refractive index of water with respect to air. Of course, children, they will say with respect to air only. Don't take by A always. Okay. So refractive index of water is 1.33. Question is, what is the value of refractive index of air with respect to water? So children, refractive index of water with respect to air is 1.33. What is refractive index of air with respect to water, he is asking. Okay, children. So refractive index of air is how much, children? 1. So he is asking reverse. Refractive index of air by refractive index of water means 1 by 1.33. So refractive index of air
100 by 133.
100 by 133. You will get approximately 0.75, 0.75. Okay, children. Next question. Try to understand, children. All these questions are very important. Refractive index of glass. Children, refractive index of glass is 3 by 2. And refractive index of water is 4 by 3. Question is, find the speed of light in glass and find the speed of light in water. This is the question, children. Already now only I discussed, no, children. Now only I discussed. We will use that formula, so children. Children, we will use. Okay, first one I will take, second one you take, children. Okay, first, children, refractive index formula is velocity of light in air by velocity of light in glass. Refractive index of glass is 3 by 2.
3 by 2.
This is constant, 3 into 10 to the power of 8. What is velocity of light in glass?
3 cancel. So 2 into 10 to the power of 8.
Very good. So 2 into 10 to the power of 8 meters per second is velocity of light in glass. Okay, children, like this. Understood, children? You are able to understand? Now, who will take refractive index velocity of light in water?
Velocity of
Velocity of
water.
4 by 3.
Air
Velocity
by velocity of water.
Velocity of light in air by?
Velocity of light in water.
This is
4
how
by
much?
3 is equal
4 by
to
3 is
3
equal
into
to
10 to
3
the
into
power
10 to
of
the power
8.
of 8 by velocity of water.
This will go here.
Velocity of water is equal to
See, velocity of light in water. Light in water.
velocity of light in water is
9
9
by
into
4.
10 to the power of 8 by 4.
So that is how much velocity of light in water is 2.25.
2.25
into 10 to the power of 8. Meters per second.
Very easy sums. I'm telling you, children, you should not get confused by when you're doing. You should do with lot of care. Means stability should be there, children. All the formulas, all the definitions, whatever I'm saying, if you understand, happily you can do like this sums. Next sum. One more sum, children. Refractive index of water is 4 by 3. Refractive index of glass is 3 by 2. What is the refractive index of glass with respect to water? What is refractive index of glass with respect to water? How much?
3 by 2
3 by 2
by 4
by
by
4
3.
by 3.
How much, children? 9 by.
9 by
9 by
8.
8.
That's it. 9 by 8. Over. 9 by 8. Okay, children. One more question. Very easy, children. So refractive index. What is the refractive index? Over. So next one, children. They ask it. One more question. The refractive index of water is. Refractive index of water is 1.33. Refractive index of benzene C6H6 is 1.50. Question is, what is refractive index of benzene with respect to water? Benzene is how much?
1.50 by 1.33.
1.32.
That is 1.13, approximately 1.13. Solve it, you get it. Slowly, carefully, you should do it. Nothing is very, very easy. Okay. Next one. Next one. Sixth question, children. Okay, next question. Say, children, refractive index of diamond is 1.6, and absolute refractive index of glass is 1.5. Okay. Question is, what? This is just a refractive index. This is absolute refractive index. Question is, what is absolute refractive index of diamond? This is the question. Okay, children. So question is, you are able to understand, children. So refractive index, normal refractive index of diamond is 1.6, children. Oh no, I'm sorry, children. They gave like this. Sorry. They gave, sorry. Refractive index of diamond with respect to refractive index of glass is 1.6. Absolute refractive index of glass is 1.5. What is absolute refractive index of diamond? This is the question. Okay, children. So what they said, children, refractive index of diamond by refractive index of glass is 1.6. They only said. And refractive index of glass, how much they said, children?
1.5
1.5.
1.5 is
is
So
equal to
refractive index of diamond is 1.6 into
1.6
1.5.
into 1.6.
That's it. Slowly, if you do, you'll understand everything, children. And the answer is going to be 2.4. That's it. Over. Okay, children, one more. The absolute refractive index of two media, children. Refractive index of A is 2. Refractive index of B is 1.5. If the speed of light in B is 2 into 10 to the power of 8, calculate the speed of light in A. Superb question, children. This is. It tests your knowledge. Okay, children, so slowly I will see. Refractive index of A is velocity of light in air by velocity of light in A. Again, refractive index of B is velocity of light in air by velocity of light in B. I told you, children. I told you already. Velocity of light in air, velocity of light in air, constant. This will go here and this will come here. So refractive index of A by refractive index of B is velocity of light in B by velocity of light in A. Okay, children? Refractive index of A is how much, children?
2.
B is how
1.5
much?
1.5 is equal to
into
2
Velocity
2
of
into
light.
into
10 to the
10 to the
power of
power of 8
by
by
velocity of
speed
A.
of light in A.
That's it. 2 gone, children. This will go here. This will
1.5 into 10 to the power of 8.
That's it, children. I'm telling you. If you do, you'll understand. If you do numericals, then you will understand. Don't say physics is tough unnecessarily. Small sums I'm telling. I'm not even telling tough sums, children. They're very, very easy sums I'm telling. Okay? One more question. You should not say again the refractive index is tough. Okay? So many numericals I'm telling for you. So next question, children. Eighth question. So what the refractive index, the speed of defined refractive index, the speed of light in medium of absolute refractive index. Children, refractive index of one medium is 1.5. Speed of light in that medium is 2 into 10 to the power of 8 meters per second. Find the velocity of light in any. This is the question. So we know refractive index is equal
Refractive
to
index is equal to by air by medium.
This is given.
1.5 is equal to velocity of light in air by 2 into 10 to the power of 8.
This goes
So
here.
velocity of light in air is equal to 3 into 10 to the power of 8.
Meters per second. Oh, that's all. This time they asked it 8 children. Okay, ninth question. Okay, next one. One second, children. One second. They have given. Okay. So the speed of light in air is 3. Find the absolute children. Speed of light in air is 3 into 10 to the power of 8. That is no need to discuss. There is some medium where speed of light is 1.4 into 10 to the power of 8. What is the refractive index of this medium? That is the question.
Medium by air.
Air
Velocity
by
of light
medium,
in
sir.
air by velocity of light
Velocity
in
of light in medium. 3 into 10 to the power of 8 by 1.4 into 10 to the power of 8 cancel. 30 by 14. 2.1.
0.1 is the refractive index.
2.1.
Of this medium, refractive index of that medium is 2.1 children. Okay, children. So like this, basing on refractive index, they are asking questions, children. Basing on refractive index. Okay. Okay, 1 second, children. Children, they are asking me regularly one question, children. What is that question? In board exam, they are asking children. I will discuss. In board exam, they are okay. In board exam, they are asking one question, children. What is the question means? That is actually textbook question, children. That is actually textbook question. Refractive index of diamond is 2.4. What do you mean by this statement? This question they are asking, children. Okay, they may ask anything. I am saying textbook question is there like this. They may ask anything, children. Refractive index of diamond is 2.4. What do you mean by this statement? This question they are asking regularly, children. What is the meaning of the statement? Means slowly you see, children. Refractive index of diamond means velocity of light in air by
Air
velocity
by
of light in.
velocity of light in.
Wait a minute, velocity of light in diamond. This is 2.4. So 2.4 is equal to velocity of light in air by velocity of light in diamond. This you bring down. This you bring down. Velocity of light in diamond is 1 by 2.4 times the velocity of light in air. This is the meaning. What is the meaning? Now you will write, children. First you have to do like this and you have to explain. See, velocity of light in diamond is, don't say velocity of diamond, say velocity of light in diamond. Velocity of light in diamond is 1 by 2.4 times, because into times the velocity of light in air. This is the meaning. This is the meaning. Okay, children? Those who didn't understand, one more example I teach you. Suppose the refractive index of water is 1.5. Suppose the refractive index of water is 1.5. What do you mean by that statement? So first you have to derive this like this, children. So 1.5 is equal to velocity of light in air by velocity of light in glass. This goes up, this comes down. So velocity of light in glass is 1 by 1.5 times velocity of light in air. Can anyone tell the definition now? Can anyone tell me the definition?
Velocity
Velocity
of
of light.
light in glass is 1 by 1.5 times of velocity of light in air.
Fantastic, very good, very nice. So velocity of light in glass, don't say velocity of glass. Velocity of light in glass is 1 by 1.5 times the
Velocity of air.
velocity of
Light in
light
air.
in
Okay.
air. Please, don't do such mistakes. Okay, if ever anyone didn't understand, last one and three, children. Suppose the refractive index of glass is 1.7. Imagine 1.7. What does it mean?
Sir,
So
can I say?
First tell me this derivation.
Yes, sir.
Tell.
1.7 is equal to velocity of light in air by velocity of light in glass.
Okay.
Velocity of light in glass is equal to 1 by 1.7 into velocity of light in air.
Now tell the definition.
Velocity of light in glass is 1 by 1.7 times the velocity of light in air.
Okay, velocity of light in glass is 1 by 1.7 times velocity of light in air. Okay, children, like this you should. Okay, children. Okay, children. Okay, so now you understood, children. Whatever they give, you should be in a position to tell children. Okay, one more I'm giving children just for only for revision sake, children. If refractive index of some object is 1.2, some material, some say like let me say kerosene. Kerosene is 1.2. Okay, anyone who will tell?
Sir, can I tell?
Tell me.
So 1.2 is equal to velocity of light in air by velocity of light in kerosene. Velocity of light in kerosene is velocity 1 by 2 times the velocity of light in air.
No definition.
So velocity of light in kerosene is 1 by 1.2 times of velocity of light in air.
That's all. The velocity of light in kerosene is 1 by 1.2 times velocity of light in air. Like this, they're asking children. This is the standard question, textbook question. This is all I gave for you to understand the question, children. Okay, children? You understood, children, everyone?
Yes, sir.
Yeah, children. So like this on refractive index, different varieties of questions will come, children. So whatever will be the question, you should be in a position to do, children. Just one the last example I want to give. The refractive index of medium A is 2 by 3. Refractive index of medium B is 3 by 4. Question is, what is the refractive index of B with respect to A? B with respect to A.
3 by 4 by 2 by 3.
3 by 4 by
2 by 3.
So this will go here, this will go here.
So 9 by
9
8.
by
1
8.
point.
Like this, children. You should be in a position to do like this questions. Okay, children. So refractive index definition is velocity of light in air by velocity of light
Velocity
in
of
given
mid.
medium. Okay, children. Velocity is equal to frequency into wavelength by frequency into wavelength. But frequency will never change, children. Frequency if you
Cancel.
refract wavelength in light in air by wavelength in medium also we can take. Wavelength of light in air by wavelength of light in medium also you can take. Sad digital, you how like that you should not think. You should be in a position to do it, children. Frequency will never change. How many mediums it change, frequency will never change. So instead of velocity in air by velocity of light in medium, we can take wavelength of light in air by wavelength of light in medium. Wavelength of light in air by wavelength of light in medium. Medium also you can take. Okay, like this we can take. Okay, so some more numericals examples I'll put in the description. More so today numericals, everything I'll put in description. Try to practice them. Thank you so much.